Welcome back to Key Safety Talks. We're your go-to for all things safety, and today, we're diving into something that might seem basic at first,
Yeah,
tool and machine safety. I mean,
right.
we use this stuff all the time.
Every day.
But when we really dug into the research,
Mm-hmm.
I'm talking guidelines,
Yeah.
handbooks, even diagrams.
Yeah.
It's way more than meets the eye.
Oh, it really is. And one of the most surprising things,
Yeah.
statistically, you're more likely to get hurt by a hand tool
Really?
than a huge machine.
I know, right? You'd think it'd be the other way around.
Yeah.
Those big machines seem way more dangerous.
You'd think.
But it's the everyday stuff we get too comfy with.
Exactly.
So we're going to figure out why that is,
Okay.
and more importantly, how to stay safe,
Yeah.
whether you're using a hammer or some high-powered press.
And it's not always the big dramatic accidents, you know?
Right.
It's the sneaky stuff that builds up over time.
Because like what?
Like using a screwdriver the wrong way.
Uh-huh.
You can get something called trigger finger.
Trigger finger. Okay, that sounds kind of serious.
It is.
And our sources mentioned it's a risk for anyone using buttons and switches a lot,
Oh, yeah.
which is basically all of us these days.
Pretty much everyone, yeah.
So not as fun as it sounds, I'm guessing.
Definitely not. It's this painful tendon inflammation in your finger makes it hard to bend or straighten.
Ouch.
Yeah. And it's a real problem if your job needs lots of hand movements.
Yeah, that makes sense.
But it's just one example of the hidden dangers we'll be talking about today.
Okay, so let's get into some real-world examples to see how this
Okay.
plays out. We found this case study.
Mm-hmm.
It really shook me up.
Yeah.
It involved a worker back in October 2014
Okay.
who was tragically pulled into a wood chipper.
That case is a harsh reminder of why safety is so important,
Yeah.
especially around powerful machines.
Right.
The investigation found the wood chipper didn't have the right safeguards,
Wow.
which led to the fatality.
That's heartbreaking.
Mm-hmm.
And it really shows that complacency can have awful consequences.
Absolutely, no doubt about it. And it shows why a multi-layered approach to safety is so important.
Okay.
When our sources talk about machines safeguarding,
Yeah,
they use this analogy of a fortress.
I like that.
You've got your guards, your distance, and then protection right at the point of operation,
No, way of operation.
where the action and the risk is.
Right. So let's break down those layers.
Okay,
Guards, I'm guessing, are those physical barriers.
right. The ones keeping you away from danger.
Exactly.
But even guards have to be designed and installed correctly.
I bet.
You wouldn't believe how detailed these guidelines are.
Really?
Like Table 13-1 in our engineering handbook,
Uh-huh.
it actually lists the exact distances needed
Wow.
based on how big the openings in the guard are.
So they've got it down to a science.
They do. It's impressive.
So even a tiny gap can be a big deal.
If it's not accounted for, yeah.
Wow. And then you have the concept of distance as a safeguard itself.
Right.
It's like a buffer zone around a power line.
Exactly. You don't need a physical barrier, but the distance is the protection.
That makes sense. But how do they figure out what's a safe distance? Is it just a guess?
Oh, no, it's not random at all.
Yeah.
There are standards and calculations involved.
Okay.
It's not just about the person operating the machine.
Right.
It's about anyone nearby, even if they're not working on it.
Which reminds me of another case study
Okay.
from April 2014, this one.
Hmm.
A worker was fatally injured
Oh, no.
because of not enough guarding distance.
Yeah.
And the company got hit with a $56,000 fine.
That's a big one.
Yeah, a real wake-up call for any business owner.
Absolutely. These cases really highlight that safety isn't just about the rules.
Right.
It's about a culture where everyone knows the risks and takes responsibility.
I like that. So we've talked about guards and distance.
Mm-hmm.
What about that third layer, the point of operation protection?
Okay.
What does that actually mean?
This is where it gets really interesting. It's all about protecting the exact spot where the work happens, where the machine interacts with the material.
I see.
And it often needs some really clever solutions.
Like what? Give me some examples.
Well, you've got everything from sensors that stop the machine if someone gets too close, to devices that pull the operator's hands out of the way.
Wow.
It's like the machines are looking out for us.
That's amazing. I'm picturing some futuristic stuff here.
It is pretty advanced.
But what really caught my eye in the diagrams were two-hand control devices.
Oh, okay.
It looks like you need both hands to run the machine,
Right.
which seems like a smart way to keep fingers away from the danger zone.
You got it. The design makes the operator use both hands,
Yeah.
so they can't reach into the point of operation.
And figure 1314 shows it perfectly.
Yeah, you can see how you couldn't do it with one hand.
I'm guessing there are ways to stop people from trying to cheat the system too, right?
Oh, yeah, they've thought of that.
Like, what if someone tries to rig it to use just one hand?
These devices have things like anti-tie-down mechanisms, so you can't trick them. It's all about making sure those safeguards can't be messed with.
That's so smart. It's like a constant battle
It is.
between people being clever and safety engineering.
Right.
But speaking of cleverness,
Yeah.
let's not forget those simple hand tools we started with.
Yeah,
They may not have all the fancy stuff of a big machine,
true.
but they're still a big risk.
Absolutely, and that's probably why they cause so many injuries.
Yeah.
We don't think they're as dangerous.
Right, they seem so familiar.
Exactly. And one of our sources, hand tool hazards and safe use,
Uh-huh.
it really gets into this.
So what are some common hand tool hazards? Besides the obvious, like hitting your thumb with a hammer.
Well, even something small, like a loose handle
Right.
or using the wrong size wrench can be a problem.
Yeah.
And it's often the little things we miss,
Like what?
like not storing tools properly or using a screwdriver as a chisel.
Oh, I've done that.
People do it more than you'd think.
Okay, yeah. I'm guilty of that.
But it's a big no-no in the safety world. A screwdriver can snap under pressure and really hurt you.
Yikes.
The takeaway here is even with hand tools, you got to pick the right tool.
Right.
Keep it in good shape and store it safely. It's about respect, really.
Respect for the tool?
Yeah, and respect for your own safety.
That makes sense. And that respect goes beyond just when you're using it.
Mm-hmm.
It's about a safe environment overall, right?
For sure. A messy workspace with tools everywhere is an accident waiting to happen.
Yeah.
So being organized and clean is just as important as knowing how to use the tool.
Okay, so we've covered a lot.
Yeah.
The hidden dangers of hand tools.
Yeah.
The fortress idea of machine safety.
Right.
And respecting the power of tools.
It's important.
Whether they're simple or complex.
Absolutely.
But there's one safety feature I find really cool.
Oh, yeah.
Have you ever thought about how machines stop themselves from going crazy?
Going crazy.
Yeah, like repeating a dangerous cycle.
You're talking about anti-repeat mechanisms?
Is that what they're called?
Yeah, they're the unsung heroes of machine safety.
Okay, got it.
And yeah, they're incredibly clever.
So how do they work?
Basically, they make sure a machine only runs one cycle at a time.
Okay.
So once it's done, it won't start again until the operator makes it go.
So it's like a built-in pause button.
Exactly.
Right.
And it stops those unexpected restarts that could catch someone off guard.
Especially if they're still near the machine.
Yeah,
This all ties back to that wood chipper accident.
it does.
If that machine had an anti-repeat mechanism,
Mm-hmm.
the worker might have had time to react.
Maybe even prevent the whole thing.
That's a scary thought.
Yeah,
But it really shows how those small details can be life-saving.
they really can. It's all about understanding how the safety features are meant to protect us.
Not just how to use the machine.
Exactly.
It's kind of like, going through all this stuff, it made me realize tools and machines aren't really dangerous on their own.
Right.
They're meant to help us,
Right.
like make work easier, maybe even improve our lives.
Totally.
Yeah.
One of the handbooks even said something like, since the beginning of time, tools have extended human capabilities. Over time, tools became more sophisticated.
Oh, I like that.
It reminds us these things are supposed to help us progress.
Right. It's like driving a car. I mean, a car is awesome for getting around, seeing new places, freedom, but you gotta respect its power.
Right.
If you drive crazy, ignore the rules,
Yeah.
it can be really dangerous.
That's a great analogy. It shows how important a whole approach to safety is. It's
Mhm.
not just about the right safeguards. It's about everyone understanding the hazards following the procedures.
Yeah, and taking responsibility.
Exactly.
So awareness is really the foundation of it all, wouldn't you say?
Absolutely. Knowing the dangers, understanding how those dangers can cause accidents,
Yeah.
and knowing what we can do to stop those accidents, that's where it starts.
And speaking of dangers,
Yeah.
one thing that surprised me was just how many hazards there are with tools and machines. I mean, we talked about the obvious ones, like getting hit by moving parts or flying debris,
Right.
but there's a whole other side to it, isn't there?
Oh, yeah, definitely. Things like noise and air contaminants, for example. You might not see an injury right away,
Right.
but being around too much noise or bad stuff in the air,
Yeah.
that can lead to some serious health problems down the line.
It's like a slow burn.
Yeah.
You don't even realize the damage until it's too late.
That's a good way to put it.
And then there's heat vibration, even the power sources themselves.
Oh, yeah.
Electrical hazards, flammable fuels, hydraulic systems.
It all adds up.
It's a lot to think about.
It is.
It's not just one or two things. It's the whole system
The big picture.
and how it all interacts.
Exactly. And it's about being proactive,
Yeah.
thinking about problems before they even happen.
We've been talking a lot about protecting people from the machines.
Right.
But is there ever a need to protect the machines from the people?
That's an interesting question. I don't think people ask that enough.
Yeah. And the answer is yes, absolutely.
Right.
Sometimes workers can accidentally damage machines.
How?
Maybe they don't have enough training or they don't follow the procedures,
Right.
right?
Oh, okay.
And that can cause malfunctions, less productivity, or even accidents later on.
So how do we stop that?
Well, like most things in safety, it starts with education and training.
Right.
Operators need to know how to use and take care of the machines.
Right.
And having clear procedures, checklists, regular inspections can help prevent damage.
And communication is important too, right? If someone notices something's off with a machine, they should feel okay saying something.
Absolutely. Open communication is so important for any safety program.
Yeah.
Workers need to feel like they can report problems without getting in trouble.
Right.
And managers need to listen to those reports.
And take action.
Exactly. Investigate and fix problems quickly and effectively.
It's a two-way street for sure.
It is.
Workers and management working together, looking out for each other and the equipment.
Yeah. That makes everything safer and more productive.
Exactly. It's teamwork all the way.
Okay, let's get back to machine safeguarding for a bit.
Okay.
We talked about the 3 layers: guards, distance, and point of operation protection.
Right.
But even within those, there are so many choices.
There are.
It's almost overwhelming.
It can be, especially when you're just starting out.
Yeah.
But luckily, those engineering handbooks we mentioned, they're really helpful. They break it down into the different types of guards.
Okay.
When to use them, the standards they need to meet, it's all pretty clear.
So how would you choose the right safeguard for a specific machine?
Okay, well, let's say we have a machine with a rotating shaft.
Like a what?
Like a drill press or something.
Okay.
Usually an enclosure guard would be the best choice.
What's that?
It completely surrounds the hazard.
Okay.
Creates a barrier that's hard to get past.
Makes sense.
But if you need to get to the shaft a lot,
Like to load stuff or adjust things?
right, then an interlocked guard might be better.
What does that do?
It stops the machine automatically when the guard is open.
Oh, so you're still protected even when you're working near the hazard.
That's the idea.
So it's about finding that balance
Yeah.
between safety and being able to do the work.
Exactly. You want it to be safe but not get in the way.
And it's not always an easy decision.
Right.
Oh,
No, sometimes you need a mix of safeguards.
okay.
Or you might have to tweak a standard one to fit the machine.
Right.
That's where the art of safety engineering comes in.
It sounds like there's a lot of creative thinking involved.
There is, for sure.
But we can't forget those point of operation safeguards.
Right.
The ones that protect people in the most dangerous spot,
The danger zone.
where the machine is actually working.
Yeah. And our sources talk about a ton of different ones.
I bet some are pretty high tech.
Oh, definitely.
Yeah.
Like those presence sensing devices you mentioned.
Those are still blowing my mind.
It is
The
amazing.
machine can sense you're there and stop itself
It's like it has a sixth sense.
before an accident even happens.
Pretty cool, huh?
Yeah. And there are different types of those sensors too, right?
Oh, yeah. Each with its own strengths and weaknesses.
So, like, what are some examples?
We've got photoelectric beams, radio frequency fields, even mechanical ones.
Wow.
So many choices. It all depends on what the job is and what kind of hazard you're dealing with.
So, how do you know which type to use?
That's where a good safety assessment comes in.
Okay.
You have to consider the size and shape of the danger zone, how fast the machine moves the environment. It's in things like dust or light can affect some sensors.
Sounds complicated.
It can be, yeah. There's a lot to think about.
So you need to really know the machine and the job.
You got it. And that's why it's so important to talk to experts and really figure out the risks.
Right before you pick any safeguards.
Exactly.
So presence sensing devices are super high tech, but what about those pull-out devices?
Okay.
Are they as intense as they sound?
They are pretty dramatic. They're usually used on machines with those back and forth or side-to-side movements.
Yeah.
Where there's a big risk of getting caught. So, yeah, they basically yank your hands out of the way if you get too close.
It's like a last resort.
It is. But all the other safeguards should stop things from getting that bad.
Right. Hopefully it never gets to that point.
But it's good to have that extra protection just in case.
And of course, we can't forget about those 2-hand control devices.
Those are great.
They seem really good at keeping hands out of trouble.
They are. The idea is pretty smart.
Yeah,
You need both hands to start the machine.
right.
So neither hand can be near the dangerous part while it's running.
And they have those anti-tie-down things so you can't cheat.
Exactly. Safety engineers have thought of everything.
They have. But even the best safety features are only as good as the people using them.
Right.
Training, awareness, following the rules, those are what make it all work.
Speaking of training, I noticed a lot of our sources talked about machine motions.
Yeah, understanding those is important.
Can you explain that?
Sure, there are 5 basic types of motion, each with its own dangers.
Yeah. Rotation, reciprocating, or transverse motion, in-running nip points, cutting actions, and punching, shearing, and bending actions.
Okay, that's a lot.
It sounds like a lot, but once you get it, it makes sense.
So knowing these motions is really important for anyone working around machines.
Absolutely.
All right, let's break them down.
Okay.
Rotation, I'm guessing, is just something spinning.
Exactly. Think of a drill bit or a saw blade.
Okay,
Anything spinning can catch clothes or hair and pull you in.
got it.
And even a smooth spinning shaft can be dangerous if it's going fast.
I bet.
The key is keeping a safe distance and knowing you could get tangled up.
What about reciprocating or transverse motion?
That's back and forth or side-to-side movement,
Like a what?
like a power hacksaw or a stamping machine.
Okay.
The danger is getting caught in the way of the moving part.
So again, distance is key.
Yeah, and knowing how the machine moves.
We already talked about in-running nip points.
Right.
So what about cutting actions?
Pretty self-explanatory, I think.
Yeah, anything that cuts can hurt you.
Saws, milling machines, lathes, anything that cuts through material could cause cuts or amputations.
And finally, punching, shearing, and bending actions.
Those are the big ones.
Yeah, those sound serious.
They usually involve shaping metal with a ton of force.
Like what kind of machines?
Sheet metal presses, bending brakes, things like that.
Okay.
The main danger is getting crushed, so safeguards are super important for those.
It sounds like learning those 5 motions is like the key to understanding machine safety.
I like that analogy. It's like learning the language of safety.
Yeah, once you know the words
You can spot the risks.
and take the right steps to be safe.
Exactly.
And that brings us back to hand tools,
Good old hand tools.
which can be just as dangerous if we're not careful.
Right, and they probably cause so many injuries because they seem so simple.
We get complacent.
Exactly, that's when accidents happen.
So what are the main things to remember about hand tool safety?
The most important thing is using the right tool for the job.
That sounds basic.
It is, but you'd be surprised how many people try to use the wrong tool.
I bet.
And that can cause a lot of problems.
It's like trying to source a square peg into a round hole.
Exactly. It's just not going to work.
And sometimes it's really dangerous,
Right. And keeping your tools in good shape is important too.
like sharpening blades and stuff.
Yeah. Things like loose handles, dull blades, damaged parts.
Okay.
Those can all make it more likely you'll get hurt.
It's like driving a car with bad tires.
Exactly. Sooner or later, you're going to have a problem.
And of course, there's storage.
Right.
Seems like a small thing.
It is, but leaving tools everywhere can cause trips.
Yeah.
And sharp tools need to be put away safely so nobody gets cut.
So it's all about having a safe and organized work area.
For sure. For you and everyone
A
else.
craft part of respecting tools.
It is.
Even when you're not using them.
Right. It shows you care about safety, your safety and everyone else's.
One thing that really stood out to me in all this research was ergonomics.
Ergonomics, it's huge.
It's not just about avoiding those immediate injuries.
Right.
It's about protecting our bodies from the long-term effects of doing the same motions over and over.
The repetitive stuff.
Yeah, and awkward positions and using too much force.
It's not just for people in tough jobs either.
Like construction.
Yeah, construction or manufacturing. Anyone who uses hand tools a lot can get ergonomic injuries.
So like mechanics, carpenters, gardeners, even office workers.
Even office workers, especially if they're on a computer all day.
That's me. I'm hunched over my keyboard all the time.
I know the feeling.
It's not good for my back or wrists.
No, it's not. But there are things you can do.
Like what?
Well, choosing tools with comfy grips is a good start.
Okay.
And paying attention to your posture and how you use the tool.
Right.
Those diagrams we looked at, figures 13-1 and 13-2,
Uh-huh.
they show how even small changes can make a difference.
They're pretty cool.
Yeah.
It's amazing how much we can do to protect ourselves
Yeah.
just by making a few little changes.
It's about working smarter, not harder.
I like that.
Being productive and safe at the same time.
Okay, so we've got hand tools and ergonomics.
Mm-hmm.
What about portable power tools?
Those are a whole other ball game.
They seem like they could be even more risky.
They are. You've got the hazards of hand tools, plus the power of electricity or compressed air.
Right. It's a recipe for trouble if you're not careful.
Exactly.
So what are the main things to think about when using portable power tools?
Well, just like with hand tools, you need the right tool for the job
Okay.
and make sure it's in good condition.
Right.
But you also have to think about the power source.
So like making sure cords are grounded and not frayed.
Exactly. And that hoses for air tools are connected properly and not damaged.
Right. You don't want to get shocked or have a hose come loose.
That would be bad. It's about respecting the power of those tools
Yeah.
and taking precautions.
And following the procedures.
Always.
Wearing the right PPE.
Like eye protection and gloves, yeah.
And never taking shortcuts.
Those shortcuts might save time now,
Yeah.
but they can cause big problems later.
I saw that some portable power tools have those dead man switches.
Oh, yeah, those are great.
What are those for?
They automatically shut off the tool if you lose control.
So if you drop it or let go of the trigger?
Exactly.
Okay.
It keeps the tool from running if nobody's holding it.
That's a good idea.
It's a safety net in case something happens.
And some tools have guards or shields, too.
To protect you from flying debris or touching the moving parts.
So it's a mix of good design and safe work practices
That's the winning combination.
that keeps everyone safe.
It's not just about today either.
Right.
It's about protecting your health in the long run,
Creating a work environment where everyone can be healthy.
both physically and mentally.
Okay, we've covered so much today.
We have.
From hand tools to machines safeguarding ergonomics, portable power tools, and how our behavior affects safety.
It's been a whirlwind tour.
But before we wrap things up,
Yeah.
I want to step back for a second.
Okay.
We talk about so many specific things,
Right.
but what does it all really mean? What's the main message?
It's all about this tool and machine safety. It's not just rules you follow.
Yeah.
It's how you think about work, being aware, taking responsibility, always trying to get better.
So we need to change how we see things.
I think so, yeah.
Instead of just seeing tools and machines as objects,
Yeah.
we need to remember they're powerful,
Right.
and that power can be good or bad.
It's like anything else, right? Too much of a good thing.
Yeah.
It's about finding that sweet spot.
Right, using that power to do our jobs better,
Exactly.
but always remembering they can hurt us if we're not careful.
Couldn't have said it better myself.
And it's not just about us.
Right.
It's about everyone around us, too.
Yeah, our coworkers, our families, everyone.
They depend on us to work safely.
It really is about taking care of each other, not just ourselves.
I like that, creating a culture where everyone feels safe and valued.
That's what it's all about.
Okay, so we've got the right mindset.
Okay.
We know the risks. We're all about safety.
Mm-hmm.
What do we actually do to make it happen?
Well, one big thing is having clear procedures
Okay.
for any task using tools or machines.
Right, so a step-by-step guide.
Exactly. And those procedures should say what to do, what the dangers are, and how to stay safe.
And it's not enough to just write them down.
No, they need to be clear, easy to understand, and followed every single time.
So making safety a habit.
Yeah, something you do automatically.
Part of the routine.
Exactly, and training is a big part of that.
Not just when you start a new job.
Right. It's got to be ongoing refresher courses to remind people.
Yeah.
Keep everyone up to date on the latest guidelines.
It's like anything else, the more you do it.
The better you get.
And safety's no different.
Exactly. And the other piece is communication.
Okay.
Making sure people feel comfortable talking about safety.
Asking questions. Reporting problems.
Exactly. That's so important.
So it's a two-way street.
It is.
Management needs to listen, and workers need to feel like they can speak up,
That's how you create a culture of open communication
where everyone feels involved in safety.
and that their ideas matter.
One thing I kept seeing in the research was inspections,
Inspections, those are key.
making sure the safeguards are actually working.
It's like a checkup for your safety program.
I like that.
They help you catch problems before they become accidents.
And we can spot trends, figure out what needs to change.
Exactly. And make sure your safety measures are keeping up with the times.
And inspections shouldn't just be about the machines, right?
No, you got to look at the whole work area.
Tripping hazards, bad lighting, ventilation.
Everything that could be a risk.
It's taking that big picture approach again.
Safety isn't just about the tools and machines. It's about the whole environment.
And even with the best plans, accidents can still happen.
That's true.
So we need to be ready for emergencies.
Absolutely. Having a good emergency plan is so important.
Yeah, everyone needs to know what to do.
In case of fire explosion, chemical spill, medical emergency, anything.
Know where the exits are, how to use a fire extinguisher.
How to call for help, all of it.
And it's not just knowing what to do.
Right, you got to practice.
So you can react quickly in a real emergency.
Practice makes perfect. That goes for safety too.
The more you practice,
The more it becomes automatic.
you don't even have to think about it. You just do it.
And emergency preparedness isn't just about the immediate response.
Right.
It's also about making sure people can recover and come back to work safely,
So creating a culture where people know they'll be taken care of.
physically and mentally if something goes wrong.
So it's about a complete safety program
Yeah.
that covers everything from prevention to response to recovery.
It's about making safety part of everything the company does.
Yeah.
And making sure everyone knows safety is their responsibility.
This has been a really insightful conversation. I've learned so much about tool and machine safety.
Me too.
And I hope our listeners have too.
It's been great talking with you.
And I hope everyone listening is thinking about safety in a new way.
Yeah. And feeling inspired to make things safer at their own workplaces.
Before we go, I want to leave everyone with one last thought.
Okay.
Safety isn't just about rules. It's about caring for each other. It's about knowing we all deserve to be safe at work
We do.
and always trying to improve.
Well said.
Remember, even small changes can make a difference.
They can.
So as you go about your day, think about the hazards, follow the rules, and speak up if something doesn't seem safe.
Don't be afraid to say something.
Thanks for joining us on Key Safety Talks.
Until next time.
Stay safe out there.